Good afternoon, everyone. I'm John Kang. I work for Cox Automotive, and I'm going to be spending the next 20 minutes talking about how we at Cox Automotive solved and are continuing to solve some of our capacity-related challenges using a combination of Python and Dash Enterprise. So a quick introduction to the company I work for and myself. If you're not familiar with Cox Automotive, we produce a lot of business-to-business products. You may know some of our online brands like Auto Trader, Kelley Blue Book, Dealer.com. We're owned by Cox Enterprises, approximately 50,000 employees under the Cox Enterprise brand, with about $22 billion in revenue. A sister company, Cox Automotive, is Cox Communications, the cable company. The specific business unit I support is called Manheim Auto Auctions. So about 18,000 employees, $3 billion in revenue, largest North American auto auction network in North America. And we were facing a problem with determining how much skilled labor and equipment we needed across our 50-plus US auto auction sites. And my specific task and role was in planning and analytics to help plan for skilled labor and equipment across these auto auctions. So quick executive summary. I'm not going to touch on all these points, but at a high level, we were faced with this problem. How much equipment do we need? How many people do we need across our auctions with varying demand at 50-plus sites? We needed a scalable, reliable solution that could work not just for technical users, but business users as well. This needed to be interactive. It needed to be a data application, not a dashboard. And it needed to be easy enough for non-technical business users to use. So getting into our challenge, right? We needed to support decision support for site staffing and equipment investments. So diving into the problem. So picture summer, fall 2020. We're coming out of the COVID restrictions. A couple of our key clients wanted us to quickly ramp up our capacity. And at Manheim, we had this operational capability called reconditioning. So reconditioning is where you repair, restore, and renew a vehicle. So for two sides of the business. Wholesale, we're supporting the auto auction. So a car may come from a dealer or a commercial client. It may not operate because the batteries don't work, the tires are flat. We'll perform that work so it can go through the auction. And the second side of the business, it's called the retail side of the business, we will recondition a vehicle for a dealer so that it can go to a consumer. So say you're buying a car online, possibly some of these cars may be reconditioned by us, but you may not know that. So we're facing these challenges. We had high amounts of growth, and we weren't able to fully support this growth. We were running into operational challenges. We had high overtime. We weren't meeting our customer service level agreements. So I was tasked with determining what was the optimal level of equipment and people based on our historical averages and models of demand and supply. Demand is cars we need to recondition, and supply is like how many people do we have? And we're not talking about unskilled labor, we're talking about technicians. So if you think of like, say, a mechanic shop, right? You've got technicians there. As you know right now, right? Hiring is difficult. Hiring was difficult back then as well. It took time to ramp up and as well hire people. So we needed to know beforehand how many people we needed. And as well, we had equipment with long lead times. So the two main pieces of equipment that we needed to plan for were lifts. So if you think of a mechanic shop, you need to lift the car up so you can work underneath it. And then as well, so that you can change the tires, work on brakes. And then the paint. In the body shop, you need to have paint booths, and this is where you could paint and cure paint on a vehicle. So as you all know, the business analytical tool of choice is Microsoft Excel, right? So we started building these models in Excel, bringing in data, and initially we could answer these questions, right? Site X was going to have 100% increase in demand. Can we meet the challenges, right? We could go through the Excel modeling process and answer these questions. But as the volume of questions increased and the complexity of the questions increased, Excel broke, right? As you know, Excel is not really a scalable solution, not reliable, doesn't have real-time information within it. So we're looking at alternatives, right? We had two alternatives that we were considering. One is going with a consulting company. So we had consulting partners that said that they could build this, right? They had development teams, they could have a front-end, back-end team, build a custom software solution. Problem with that, as you all know, is it's very costly to go with consultants. And secondly, it would take a lot of time and energy to integrate with our existing systems. And then secondly, we could buy an existing capacity supply chain software solution. But due to the unique nature of our operation, a lot of these software solutions were built with the manufacturing operation in mind, right? So it would take heavy customization, a lot of time, and a lot of money. And these were things we did not have. We did not have a ton of money up front. We didn't have a lot of time. We needed to answer these questions quickly, as you all may have problems. So what we started doing is migrating off of Excel and building it into Python, right? We were using Excel and Alteryx to update our data, build our models. That wasn't working. We started migrating into Python so we could increase the velocity and speed and complexity of the questions we were answering. And the next step to that was considering how do we visualize this and make this interactive, right? And in the Python space, like you've got a number of different dashboarding, web framework libraries out there, but the one we knew of and that was most popular, most customizable was Dash. So we started building a proof of concept in Dash open source, and I'll get into a little bit more why. So we started going to Dash Enterprise. We started going to Dash open source, and we weren't able to fulfill all the customer demands. So in terms of two aspects. One is security. As many enterprises have concerns about security. We were using the open source software. I was managing authentication. It wasn't a great experience. We needed to upgrade and have a path so that we can integrate with our existing security tools like Okta and our own authentication. And then secondly, we needed the application to look and feel like other data applications that we had within our portfolio so that it could increase trust and user adoption across our 50-plus sites and corporate leadership. To accelerate this, we decided to upgrade to go from Dash open source to Dash Enterprise. One, it was like fairly seamless, and secondly, we were able to fulfill the requirements of the theming and branding, and as well the security. Just kind of double-clicking on why Plotly and Dash. As many of you know Plotly Express, Dash, a lot of downloads, 16 million plus downloads per month of Plotly visualization libraries, 2+ million downloads per month of Dash, a lot of GitHub stars, so it's really well known. It's not some software company that's gonna go away next year. And that's why we decided that we should, because of not just the trust in the community, but also the customization and the flexibility of Dash, we decided to go down that path to build this internal data application. So going into more of why Dash Enterprise and Plotly Professional Services, we were a small team, right? I had a team of myself and one other industrial engineer. We weren't professional software engineers, we weren't Python developers, kind of data scientists, right? So we needed some help. So we were canvassing our other partners. We had other consulting partners that would offer up Python developers, but they really didn't have the expertise in Dash and really wanted to go down the path of Dash versus using Angular, React, or other front-end libraries. So we decided to start incrementally investing in a relationship with Plotly Professional Services. Plotly is the company behind Dash, and they've got a small, great team of developers that understand the Dash Enterprise library. They've built apps day in, day out, so they could accelerate our development of these tools, and then secondly, they bring along development best practices. Like I talked about, we weren't professional developers. We needed to learn some best practices like CI/CD, code reviews, app testing, committing code into repos. And then lastly, this team was very experienced with UI, UX, and branding applications to fit corporate styling guides. So we were able to work with the Plotly Professional Service team and our UI, UX team to ensure that the application looked and felt like other internal tools. It didn't look like some generic web application, that people couldn't trust, right? It looked like our other internal apps. So this is a GIF of one of two main pages. So this is the multi-site view. So this view was built with two main users in mind, our corporate and our regional leaders. And with our corporate and regional leaders, what they really needed to do was, at a slice of time, be able to see demand and supply and capacity across multiple auctions at a time. So here we're selecting a time frame. So this is April 2023. We're selecting my region. We're in Georgia, so we're in the Southeast. And as you can see, it's pretty quick, but you can see red, yellow, green. At a quick snapshot, you can look, hey, in my region, these auctions we have concerns about. I need to double click on them. Or these auctions are green. Maybe we need to bring in more demand or shift demand, right? And you can also click on all auctions. So as you can see here, 2 points here. One is the speed. Like you can see that as we click and as we change things, models rerun, things regenerate. So it's very fast, it's real time. And secondly, it's on brand with our other internal data applications. We've got, as you can see on the left-hand corner, the little M, that's the Manheim brand. The colors match, the look and feel match other applications that we use internally. The next slide I'm going to show is our single site application, and this is the last of the two main pages in our application. And this is what's built for two main purposes. One is for a site's users and leaders, from the general manager on down, to be able to really see that capacity over time at their site. And secondly, it was built to be able to do scenario planning. And the way we define scenario planning is we feed the model with good defaults of data and demand and forecasts, but with scenario planning, you can change this. So in here, you can see that you've got some data cards showing data and graphs on like how we're doing in terms of capacity. If you click on scenario planning, there's a number of different inputs we can change. In this specific use case, they're changing proficiency. So proficiency is a term very specific to the auto industry, but it's a measure of the efficiency of how efficiently a technician can convert their own hours into billable hours. So if you've ever gone to a dealership or mechanic shop, you may be billed hours. These are like industry standard terms, right? Like if you get billed 2 hours, if a technician can do that 2 hours in 1 hour, they're 200% proficient, right? So in this case, they're increasing their proficiency. So in this fictitious example, we're investing heavily in IT and process improvement so that they can be more efficient. And as they do so, it changes the amount of capacity available to bring in new demand. So this is just one instance where we can show that scenario planning is very useful as things are very dynamic and change. So that was very useful for two main purposes. Right? One is to be able to, in real time, see changes in a situation, and you can model that. And secondly, be able to do that, be able to change inputs and see the output, it increased user adoption and trust because people could link the input with the modeling that we conducted mathematically with their understanding, and they could trust the outputs because they saw in real time and with their own inputs how that changed the outputs. So these are the last two main content slides. I have 6 main points of how we demonstrated a return on investment in terms of the funds and time that our leaders provided our team to be able to invest in this application. The first one is really, as I'll reiterate, we could accelerate a proof of concept into an application quickly and with a low investment of money. Secondly, security compliance. We can meet the requirements of our IT product organization regarding authentication and security. It all integrated with our current existing tools so that we had confidence that our application and the data and the models would not get out to our bad actors. Our third point, lowered barriers to use the application. Unlike Excel or other applications that we may have considered, this application is branded, it's styled, and the look and feel of it is very consistent with our other applications, and it's very easy to use. So that helped non-technical business users to be able to use the application and gain trust and increase adoption. So last 3 points. The fourth is back-end pipeline support. So this dovetails in with Python and Dash Enterprise. So Previously, like I talked about before, we were using Excel plus Alteryx to pull in data and update the data. Due to the laborious nature of that process, we're updating data, say, every week, every month. But with Python and with Dash Enterprise, we're able to update, say, in minutes or in hours, pulling from our on-premise databases, from Snowflake, our data warehouse, being able to do an ETL process, quickly aggregate the data, push it back into Snowflake. And then in Dash Enterprise, we've got a process where we can rehydrate our data, pushing into Redis and Postgres so that we can, one, be performant so that we're not tied up in network calls, getting data across the network. And secondly, any issues with like disasters or communications issues, if the database goes down, the application will still be up because we've got that built into the Dash Enterprise server. Fifthly, we can avoid full stack costs, right? In Dash Enterprise, we built the application primarily all in Python. We didn't need to learn a front-end language. We didn't need to hire front-end people. We did it all in Python. It's very performant and it works well. And lastly, it's multi-page and branded. So the multi-page aspect of this application was really helpful so that we could answer different questions across our business that specific users may have, and we can all have it within the same application. And secondly, it's branded so people can trust and understand how to use the application because it's very similar to other applications that we have internally. This is the last slide. Just to reiterate, we had a problem planning equipment and labor across our 50-plus auto auction sites. And we turned to Python and Dash Enterprise and the Plotly Professional Services team to be able to help us accelerate the development of an application and a process to answer the questions that our business has. That's the end of my presentation. I think we may have a couple minutes for questions. If anyone has questions, they could just stand up. This gentleman first, and the gentleman. Yep. Yeah.
Question was, you say you guys went from Dash OSS to Enterprise. These are key differences that you found out there for you guys.
So I'll reiterate the question if you couldn't hear. The question is, when we moved from Dash open source to Dash Enterprise, why did we do that? And why did we do so? And what were the key features that led us to do so? So I think the two main features that we talked about, and there's other features as well. One is security. You've got built-in integration with the existing authentication and software, security software already out there. So for us, we use Okta. It integrates very seamlessly with Okta so that we can ensure that everyone who's authenticated within our network can use the Dash Enterprise as long as they're provisioned. And secondly, the theming aspect. There's specific Dash Enterprise libraries, Dash Design Kit that allows us to theme very easily and seamlessly so that the application can be on brand. This gentleman here. Yeah, so the question is, were the GIFs and the animations, were they all made in Plotly and Dash Enterprise? So yes, those GIFs, they're videos of the application live working on the web as we click and as we change inputs. There's this idea of like, again, a little technical, but it's called the callback. So an input is changed, it runs a callback, it reruns models, and it shows the output again on the website.
Yeah, how did you improve performance by using Plotly versus using like regular Power BI, Tableau type applications?
That's a great question. The question is, how did we improve performance of the application versus say like Tableau, Power BI using Dash, right? I think the key feature that led us to go to Dash open source and Dash Enterprise is this idea of being able to use callbacks and be able to rerun Python models in the back end. So you change an input and you can run a whole series of models that are invisible to the user, but run very quickly in Python, mathematical models, and regenerate outputs, right? It's very difficult to do that in Power BI and Tableau. And then as well, secondly, because you're writing this all in Python, you can customize the application so it looks and feels and operates in a manner that you're not constrained by these GUI-based tools like Tableau and Power BI. I think I have time for one question if there's any more questions. This is the gentleman in the back.
You mentioned the support technicians, like how if they are faster, is a better quality, right? I mean, like you talked about the hours for the 2 hours to run the 1 hour. So what stops them once they learn that is one of the parameters, right? Being faster is like but they're losing the quality of work.
So I think the question is, what stops a user from like gaming the system and the application because they see the scenario inputs, right? So I think the key point there is there are defaults generated in our system based on the data that's coming in, that's generated like historical averages of demand and usage of equipment and labor by person and by client. They can change that and change the output, and they can generate a report. But really, if they've got key decisions to make, the leaders know that they can walk through these inputs and see the defaults and see them change it. And because it's so fast, you can reset them to defaults and then change the input again. So because of the speed and the ease of changing back to the default, you can see any input changes and how that changes the output. And those inputs that you're changing in scenario planning, they're not going to change the defaults for all users, right? It's a stateless application.
I was talking about manipulation, like how they can kind of work faster. Let's say to get paid better, right? But when they work faster, the quality of the service.
Oh, interesting. So this is an operational question, right? Like if you work faster, quality may decrease, right? Like that gets into the weeds of like the modeling of how fast we can say people can work, right? And we work with the industrial engineering team and then some of our operational excellence team members to mathematically model this to be able to put in good defaults for sustainable rates of production long-term across different auctions and by clients, right? So we don't want to just push our people to work harder and reduce quality, right? Like there is, as one of the inputs, we do have quality as one of the metrics in there, and we have quality that we are starting to measure and have as an input because we know that as quality decreases, actually production decreases, right? Because you've got rework coming in, right? I think that's all the time I have. I'll be around in the back or at the Plotly booth after this. Thank you all for the time. Appreciate it.